Before we begin our discussion on dilution, I'd like to spend some time here with a quick concept check on the molarity of specific ions in solution. We can see that we have an ionic compound, aluminum nitrate, and we know its concentration is 0.150 molar. And what I'd like you to do is I'd like you to pause the video to see if you can determine the concentration of specifically nitrate ions that will result from this ionic compound. I'll give you a moment to pause the video and we'll go over the solution momentarily. When this ionic compound dissolves, first we have its chemical formula. Aluminum nitrate is AlNO3. We know that its original concentration is 0.150 molar. In this compound, we know that there is one aluminum cation for every one formula unit of the compound. So the concentration of aluminum 3+ should be exactly the same as the original compound that dissolves. However, nitrates, there are 3 nitrate ions for every one formula unit of this compound. So since I know I'm going to have 3 times as many nitrate ions by the end of this dissolution, the concentration of those nitrate ions is going to be 3 times that, or simply just 0.450 molar. Now, anytime that we add water to a solution, we're actually causing a process called dilution. When we dilute any solution that has a particular number of solute particles per unit volume, and we add water, the water is changing the volume of the entire solution. However, the solvent that we added did not change the number of moles of solute that was dissolved in the solution. This is a very important statement because it allows us to make very quick calculations to determine the new molarity or the new volume of the solution, or even the original volume that we needed. When we dilute a solution, the number of moles of solute remains the same. We know that molarity times volume will always give us the number of moles of solute. So if I take my initial concentration and multiply it by my initial volume, that should always equal the second concentration times the second volume. Regardless of how big that volume is and how dilute the solution is, the number of moles of solute remain the same, and this equality will continue to hold. You can also look at this as an inversely proportional relationship. As the volume of the diluted solution gets bigger, the molarity heads in the opposite direction and gets smaller in quantity. So these two quantities are inversely proportional when it comes to the dilution of a mixture. In each of these beakers, we have a certain number of solute particles per unit volume. Some of these beakers have less volume and some of these beakers have less particles. There are 4 concept check questions that I would like you to answer about these particle level diagrams. So please pause the video and give yourself a chance to answer these questions, and we'll go over the solution here momentarily. In terms of which of these solutions is the most concentrated, that would be solution A. Solution A clearly has the most number of solute particles. It has about 12 here per unit volume, 500. Even if I go down to some of the solutions down here, this solution has half the volume as solution A, but it doesn't have nearly as many particles per unit volume because it only has 5, which is less than half of 12. Which solution is the least concentrated? Well, from these pictures, you can very clearly see that it's solution C. It has the most amount of volume, and in that volume, it has the least number of particles, 3, in that much larger volume, which makes that solution much more dilute. Now, in terms of which solutions have the same concentration, that would be beakers B and E. Beaker B has exactly 6 particles per 500 milliliters, and you'll see that solution E has exactly half of that volume, but then it also has half the number of particles, so the concentration for beaker E remains the same as solution B here. And then for number 4, When solutions E and F are mixed together, which solution will have this mixture as the same concentration? And that would be solution D. If I count the number of particles, I have 1, 2, 3, 4, 5, 6, 7, 8. So I need to make sure that I have 1, 2, 3, 4, 5, 6, 7, 8 particles by the end of that combination. And since those volumes are going to be additive, I can assume that this combined volume is going to be the same. When it comes to using the dilution equation to solve for various quantities, we do the same thing that we do with other types of math problems. We list our knowns and our unknowns. In this particular situation, we have 50 milliliters of a 1 molar solution of nitric acid that is required for a procedure, so that's going to be our final volume and our final concentration. How many milliliters of the original concentrated acid should be used? So I know that my equation is going to be M1V1 equals M2V2. I know that my initial molarity of my stock solution, or my more concentrated solution, is going to be 15.8 molar, and I know the two conditions that I want my final solution to be at, and I'm solving for the original volume that was required for this dilution. If I rearrange my equation, I get V1 equals M2V2 over M1. I substitute my values into this equation, and you can see that the labels of molarity are going to divide out. And that's why I'm allowed to simply substitute in milliliters, because that's going to leave the label that I need in my answer with the number that I get after I calculate all of these values. And after I finish my math, I should come out with an answer that's approximately 3.2 milliliters, which would be the volume of the original solution that was required to get this final, more dilute solution. There are two practice problems that I'd like you to try with dilution and molarity. Please pause the video and try these two problems yourself, and then we'll go over the answers to these two problems momentarily. For problem number 1, we're trying to determine the first volume that we need, which is volume 1, that's required to make a more dilute solution. So this turns into a very similar setup as our previous example where we need to solve for V1. V1 is equal to M2V2 over M1. I substitute my values in. I notice that my molarities are going to cancel, leaving me with the units that I need in my final answer. And the volume of the original solution that I needed to use to dilute to the final concentration of 0.5 molar would be 33.3 milliliters. Now for practice problem number 2, we're trying to determine the final concentration of this solution after we dilute it. We know that the initial volume was 8 milliliters, and we also know that the concentrated acid was at 12.8 molar. We want to try to get our solution to be 100 milliliters by the end of this dilution, so the rearrangement of the dilution equation gives me M2 is equal to M1 V1 divided by V2, 12.8 molar. The milliliters and the milliliters are going to divide out, and I take my numbers and I substitute them in. I get a final concentration of 1.02 molar as my final answer. Our next topic is going to be how we handle molarity when it comes to reactions in stoichiometry. And that'll be our final topic for solutions before we start talking about acids and bases.